Good morning, students. In the last class, we have discussed about the wire arc spray. In this wire arc spray, the thermal metal deposition techniques and also they have been developed to coat low temperature substrates with different metallic materials. This results in a range of low cost tools that can provide varying degrees of durability. And also the concept is to first, deploy a high temperature, high hardness shell materials and also to rapid prototyping pattern and then backfill the remainder of a two shell with an inexpensive low strength and also the low temperature materials on the cooling channels. This is the wire arc spray we have discussed in the last classes. Okay, and also the in this wire arc spray also with the help of the metallic feed wire and also the atomizing gas, we will easily declare to this we declare to this material which wires are melted with an electric arc and also the droplets are propelled towards the substrate with the high velocity of the materials. Okay, high velocity of the materials and also in this prototyping methods if a prototype if a prototype is required only for the purpose of a shape verification, a soft material and also they used as the workpiece in order to reduce or avoid any machining difficulties. Okay, in this prototype, we can easily identify of this wire arc spray. A soft material is used as the workpiece in order to reduce or avoid any machining difficulties. The material intended for use in the actual application also can be machined by this operation may be more time consuming depending on the machinability of the materials. Depending on part complexity and machining capabilities, prototypes can be produced in a few days to a few weeks. Other starting materials can also be used such as wood, plastic or metals and also the CNC machines used for rapid prototyping are often small and in the terms desktop milling or a desktop machining or sometimes used for these technologies. Maximum starting block sizes in desktop machining are typically 180 mm in the X direction and 150 mm in the Y direction and the 150 mm in also the Z direction. This is the Y arc spray which are used in this process easily depicted through the workpiece of the materials. It is a prototype which can be easily identified through the purpose of the shape verifications of a soft material, usually with a high workpiece of in order to reduce or avoid of the machining difficulties. Okay, the materials intended for use in the actual application can also be machined by this operation, maybe more time consuming depending on the machinabilities of the material. Okay, this is the depending part complexity and the machining capabilities prototypes can be produced in a few days within a few weeks of the materials. Okay, the other starting materials can also be used such as wood, plastic or metals with the help of the CNC machines used for the rapid prototyping process of the materials. Okay, this is the indirect or pattern based tooling process. Approaches use master patterns to produce a mold or die and also the indirect tooling where the additive process builds the actual molds. Okay, indirect tooling process. In this indirect tooling process also, the methods are intended as prototyping or pre-production tooling process and not production methods of the materials. Most any rapid prototyping process can yield patterns for indirect tooling of the method which we are using in the pattern-based tooling systems. Okay, and also this is the process which you are using in the indirect rapid tooling processes. One is RTV, RTV, cast, 3D Keltol, composite tooling, spray metal tooling, rim, vacuum casting, and RSP. These are the methods which you are using in this indirect rapid prototyping system. We will discuss one by one method also. How the process will be involved in the direct indirect RT systems. Okay, next techniques for indirect or RT is nothing but RSP tooling, reconfigurable tooling, silicon rubber tooling, aluminum filled epoxy tooling, spray metal tooling, cast side, 3D Kelton, and also the rim methods. Next, silicon rubber tooling methods. Silicon rubber tooling methods is nothing but one of the most popular tooling applications for rapid prototyping is the production of room temperature vulcanizing silicon rubber tooling. It is also called as RTV tooling. Okay, the purpose of RTV tools is to create urethane or epoxy prototypes often under vacuum. Hence, the term vacuum casting is nothing but with the help of the silicon rubber tooling. So same as we are keeping with the help of the mold only. Here we are keeping with the help of the tooling applications of the different temperatures and also the different prototyping methods which we are used in this rubber tooling. Okay. Same we will use a like that pattern only. Same like that pattern only we will keep with the help of the mold. Mold also we will easily obtained through the system of the materials. Okay, and also the most popular tooling applications can also be with the help of the rapid prototyping production of room temperature vulcanizing, and also the silicon rubber tooling with the help of the tools, and also they create with the urethane and also the epoxy prototypes often under vacuum pressure with the help of the silicon methods. And also the process of making a rubber mold consists of this nothing but making a master pattern usually on an rapid prototype machine, finishing the pattern up to the desired appearance, and also the casting RTV silicon rubber around the pattern to form the mold, and then injecting the mold with two-part thermoset materials to create a molded plastic parts. Okay, the process of making of a rubber mold consists of is nothing but making a master pattern usually on an rapid prototyping machine, finishing the pattern to the desired appearance, and also the casting RTV silicon rubber around the pattern to form the mold. And also the injecting of the mold with the two-part thermoset materials can also be created, and also the molded plastic parts of the systems. This is nothing but a silicon rubber tooling process. And also this with the help of the silicon rubber tooling process, the RTV systems also can be easily identified throughout the systems of the materials. Okay. With the help of the master pattern, it can be be usually on a rapid prototyping machine, and also the finishing pattern of the desired appearance will be easily identified through the product of the patterns. And also the casting RTV silicon rubber around the pattern to form the mold, and then injecting the mold with the two-part of the thermoset materials to create a molded pattern. So this is the pattern which you are using, and this is solid this RTV processor. First one, rapid prototyping pattern. This is the pattern which we are using with the help of the materials. Okay, and this pattern will be injected through the RTV molding compound materials. Okay, we are keeping the one base material, and in that base only we are keeping this mold pattern into this base material. After the base material, it will be directly injected into the this flip pattern and the mold of the second side. Here we are injected this side, and from in this injected we will fixed into this A tube, and also the filler pattern which we are injected throughout the system materials of the systems. Okay, and also with the help of the A tube and also the filler pattern, the directly injected material will be filled throughout the pattern materials. Automatically, the pattern will be mounted through the materials, and it will be directly injected into this tube process. Okay, then this tube process will be slowly mounted with the final product of the materials. These are the different steps involved in this rapid RTV systems. Okay, first one is nothing but RP pattern, rapid prototyping pattern. Next one, RTV molding compound. Third one, flip pattern, and a mold second side in the A tube, and also the filler pattern process. And this is the process which we are injected into this injected into these systems, highly depending upon the different types of patterns of the materials. Okay, and this different types of material will be highly defected through the system of the materials. Okay, system of the materials. And next fourth one is cut RTV pattern along a parting line, and also the removing a remove pattern with the help of the materials. See, if we, here we have injected the pattern. After the pattern completely over, then completely finished with the product, automatically the pattern will be removed slowly. Okay, next we should for mold, urethane or plastic material which we are giving the final product of the materials. Okay, and we will join throughout the materials, and then the plastic with filler will be removed where the mold shape will be formed into this material process. Okay, this is the process which you are using in this material process. First one is nothing but a rapid prototype. Which type of shape we are taking, we should fix that material. Okay, after that, second one is nothing but a RTV mounting compound we will take. Next, third one is nothing but flip pattern and the mold second side with the help of the air tube and the filler pattern will be fixed. Okay. Fourth one is nothing but we will cut RTV pattern along parting line, and also the remove pattern, and the mold, urethane or other plastic materials will be used. With the help of the plastic with filler will be removed throughout the materials. Okay, this is the silicone method which we are using in this RTV system. The silicone rubber tooling provides fast, inexpensive molds, excellent pattern cosmetics, and the option of using multiple materials. Okay, the process is suitable for small or medium-sized parts, and also the another benefit of silicone rubber tooling is the negative draft that can be achieved due to the flexibility of the mold material. Okay, this is the process which you are taking in the silicone rubber process. Silicone rubber tooling provides a fast, inexpensive molds, excellent pattern cosmetics, and the option of using multiple materials of the product. And also the process is suitable for small or medium-sized parts which we are taken in this process. And next one, another benefit of a silicone rubber tooling is the negative draft that can be achieved due to the flexibility of the mold material. Okay, this is the solid silicone rubber tooling or RTV system which we are using in this indirect rapid tooling processor. Okay, once we will discuss from the onwards. This is the wide arc spray which you are using in this rapid tooling processor. These are the thermal metal deposition techniques, and these are being developed to coat low temperature substrate with metallic materials, and also this results in range of low cost tools that can provide varying degrees of durability. Okay, the concept is to first deploy a high temperature, high hardness shell material to an RP pattern, and then backfill the remainder of the two shell with inexpensive, toasted, low temperature materials on tooling channels. This provides a hard, durable phase that will endure the forces on temperature of injection molding, and a soft backing that can be worked for optimal thermal conductivity and heat transfer of the body. Okay, and also if a prototype is required only for the purpose or of a shape verification, a soft material is used at the workpiece in order to reduce or avoid any machining difficulties. The material intended for use in the actual applications can also be machined through, but this operation may be more time consuming depending on the machinability of the materials. Depending on part complexity and the machining capabilities, prototypes can be produced in a few days to a few weeks. Other starting materials can also be used, such as wood, plastic, or metals of the body. The CNC machines used for rapid prototyping are often small, and the terms desktop milling or desktop machining are sometimes used for this technology processor. Maximum starting block size in desktop machining for typically order 180 mm in the x direction, 150 mm in the y direction, and 150 mm in the z directions of the materials. Indirect or a pattern based tooling process is nothing but it approaches use master patterns to produce a mold or die, and a direct tooling where the additive process builds the actual molds of the patterns. Okay, in this indirect tooling methods are intended as a prototyping or pre-production tooling process and not production methods. Most any rapid prototyping process can yield patterns for a indirect tooling process. Okay, in this indirect tooling process, there are different methods. First, RTV, cast cassette, 3D Kelthal, composite tooling, spray metal tooling, ring, vacuum casting, RSP. These are the different methods which are using in this indirect RT systems. And these techniques for indirect RT systems is nothing but RSP tooling, reconfigurable tooling, silicon rubber tooling, aluminum fixed filled epoxy tooling, spray metal tooling, 3D Keltron, and also the rim processor. Silicon rubber tooling. One of the most popular tooling applications for RT in the production is the production of room temperature vulcanizing. Means RT is nothing but room temperature vulcanizing silicon rubber tooling. Okay, the process of RTV tools is to create urethane or epoxy prototypes often under vacuum with the help of the system materials. The process of making a rubber mold consists of making a master pattern usually on an RP machine, finishing the pattern to the desired appearance, casting RTV silicon rubber around the pattern to form the mold, and then injecting the mold with two-part thermoset materials to create molded plastic parts. These are the pattern which are used in this RTV system is nothing but one RP pattern, second RTV molding compound, third one flip pattern and mold second side, and the fourth one cut RTV pattern along parting line and remove pattern, fifth one mold urethane or other plastic, sixth one plastic with filler to be removed. These are the parts which you are using in the silicon rubber cooling methods. Okay, and so we will revise in the from the first onwards. Rapid tooling. Rapid tooling is nothing but the term which is in the rapid tooling is typically used to describe a process which either uses a rapid prototyping model as a pattern to create a mold quickly or uses the rapid prototyping process directly to fabricate a tool for a limited volume of prototypes. Next, rapid prototyping is nothing but to minimize the cost, increase the productivity, increase dimensional accuracy, and also decrease the total time. Okay, rapid tooling is nothing but it can be classified into two products. One is a direct tooling, another one is indirect tooling. Indirect tooling is nothing but it used RP inserts to produce molds, but direct RT methods allow injection molding and die casting inserts to build directly from 3D CAD models. Okay, classifications is nothing but subtractive, virtual process, additive process. Subtractive is nothing but, as the name implies, subtractive process involve material removed from a workpiece that is larger than the final part. Virtual processor use advanced computer-based visualization technologies. Additive processor build up a part by adding material incrementally to produce the art. And also the traditional method of fabricating a prototype part is machining, which can require significant lead times. Computer-based drafting packages, which can produce 3D representation of parts, interpretation software, manufacturing software, CNC methods. Okay, direct metal laser sintering. In this process, the material will be directly used into this nickel and also the bronze method. A laser beam is used to sinter the materials regularly to manufacturing and core cavity inserts directly from CAD data. Okay, this technique is a layer editing technique for making the inserts. These inserts after they have been made of a different machine purpose, and also the CAD data and also the XY direction with the help of the layers. After one layer, the build platform moves of the determined throughout the product of the area. product of the area. This way, the entire prototype is built up by subsequent joining of layers. The tool life obtained from this technique is comfortably 50,000 pieces. Next, wire arc spray. Wire arc spray is nothing but it is a thermal metal deposition techniques with the help of the low temperature substrate with the metallic materials. Okay. The concept is to first deploy a high temperature, high hardness shell materials, and also the rapid prototyping pattern of the materials, and also the inexpensive low temperature materials of the tooling process. And also this provides a hard durable phase of the material which can be easily identified throughout the product of the materials of the thermal conductivity and heat transfer of the body materials. Okay, and this is the white spray which we are using in this material processor. It is an atomizing gas spray materials and also the feed wire materials which you are giving. The wires are melted by an electric arc and the droplets are propelled towards the substrate of the different high velocity of the materials of the body. And with the help of the atomizing gas, it can be directly injected into these materials, and also the spray metal with the feed wire also can easily identify throughout the metal process. Okay, yeah, it is the prototype of which we are using in the soft material of the process in the workpiece in order to reduce with the machining difficulties of the materials. And also depending upon the machinability of the material, complexity and machining capabilities prototype with the produced in 2 days and also the few weeks. Other starting material can also be used such as wood, plastic, metals with the help of the materials, and also the CNC machine used for rapid prototyping are often small and the terms desktop with the help of the materials. It has two types. So one is indirect and also the direct. Indirect is nothing but it is an indirect or pattern based tooling approaches with the help of the master patterns and also the direct tooling with the additive process of the materials. Okay. And these are the different process which are used in this indirect. RTV is nothing but room temperature vulcanizing process. Cast cassette, 3D chemical, composite tooling, spray metal tooling, rim process, vacuum casting, RSP process. And these are the techniques which are using in this indirect rapid prototyping process. Silicon rubber tooling. One of the most popular tooling applications for RP is the production of a room temperature vulcanizing silicon rubber tooling process. The purpose of RTV tools is to create urethane or epoxy prototypes often under vacuum pressures. And also the rubber wood mold consists of making a master pattern usually on an RP machine, finishing the pattern to the desired appearance, and also the casting RTV silicon rubber around the pattern to form the mold, and then injecting the mold with two-part thermoset materials to create molded plastic materials. And this is the way which we are taking the pattern of the different types of rapid prototyping system. First, we should know about the pattern. Next, we should keep the molding compound. After that, we should flip the pattern and also the mold on the second side, and all cut the RTV pattern along the pattern line and the mold pattern, and next mold urethane or other plastic materials, and last filled with silver materials. Okay, next silicon rubber tooling provides fast, inexpensive molds, excellent pattern cosmetics, and the option of using multiple materials of the materials. Another benefit of a silicon rubber tooling is the negative draft that can be achieved due to the flexibility of the mold material of the systems. This is the different types of the one of the type of the indirect rapid tooling process, that is nothing but silicon rubber tooling, and RTV process. RTV is nothing but room temperature vulcanizing process of the materials.